Hi, I'm Scott Adams, a graduate student at The Ohio State University. In this short video, I will summarize a paper I wrote with Dennis Ritsky and collaborators on the environmental dependence of the incidence of galactic tidal features. This paper has been accepted by the Astronomical Journal and is posted on astro-ph. Galaxies and clusters grow through mergers and accretion. The rate of such events is a fundamental quantity that hierarchical models of growth should be able to predict accurately. Galaxy mergers result in tidal features, such as tidal streams and shells, that can be observed and used to estimate the merger rate. For the first time, we measure the rate of such tidal features as functions of both local and global environment. We do this on a sample of over 3,500 early type galaxies in 54 nearby clusters using deep stack images from the multi-epoch nearby cluster survey taken with the wide-field megacam imager at the CFHT. We identify tidally disturbed galaxies both interactively and automatically. For the automated sample, we follow the general procedure of Tidal et al. 2009. We divide the galaxy images by best fit model galaxies created by nested elliptical isopods, and then measure the average absolute value of the resulting residual. If this is above a threshold value, the galaxy is flagged as tidally disturbed in the automated sample. With the depth of our data, we find 3% of the galaxies have identifiable tidal features. We examined the rate of tidally disturbed galaxies as a function of projected cluster-centric radius, scaled by R200. The cumulative fractions are shown in this figure. The black line is the cumulative fraction of all galaxies in our sample. The purple dotted line is the automated sample. The magenta broken solid line is the visual sample, and the cyan and green lines are the union and the intersection of the two. This plot shows the deficit of tidally disturbed galaxies within approximately 0.5 R200. A KS statistic finds that the tidal sample of galaxies was not drawn from the parent sample of all analyzed galaxies, with 98.2% confidence for the visually selected sample and 91.5% confidence for the automated sample. This result suggests that the creation and/or destruction of tidal features depends on cluster-centric radius, or more appropriately, the variation depends on a physical characteristic that drives the phenomenon and is itself correlated with cluster-centric radius. We test a straightforward hypothesis in which tidal features are more easily erased in dense environments due to a shorter dynamical time. In this toy model, we assume that the rate of incidence of tidal features is uniform with cluster-centric radius, and that the decay time of such features is proportional to the dynamical time at their location in the cluster. The result of this model is shown as the orange solid line in this figure. While this model would result in a reduction of the measured rate of tidal features at small cluster-centric radii, it possibly would not solely account for the magnitude of the deficit we observe. We also make a measurement of the rate of tidal features as a function of local density. A KS test of the cumulative distributions of tidally disturbed galaxies in the full cluster sample shows no evidence that the rate of tidal features is dependent on local density. We next attempt to remove the correlation between local density and cluster-centric radius by dividing the galaxies into cluster-centric annuli, and within each annulus, ranking the galaxies uniformly by local density to range from 1 to 10, with 10 being the most dense. We then sum the density ranks of disturbed galaxies for all density bins. A random distribution would be flat across all density bins. By doing this, we are asking whether at each radius, the galaxies with tidal features are preferentially in environments of either low or high local density. We find that tidally disturbed galaxies show no statistically significant deviation in ranks from the full cluster sample. However, we caution that this is absence of evidence rather than evidence of an absence, especially since our measurement of local density is crude. Still, we show that interesting behavior exists in the rate of tidal features as a function of cluster-centric radius, and hope that this should provide some guidance for models of merging in early types. I hope that you've enjoyed watching this video. For more information on this research, please read our paper.